All right, small solar system objects. This is posted by Haley from New York. During the summer, my dad and I go outside when it gets dark. We like to go stargazing. I have even seen shooting stars. Shooting stars are very hard to spot. You have to stare at the sky and sometimes you will see one shoot by. They only stick around for one split second, but it is really amazing to see one. This is my favorite thing to do when it gets dark in the summer. All right, so what do you think shooting stars are, and what do you like to observe in the night sky? Or have you ever gone out and observed the night sky? All right, so how do scientists classify small objects in the solar system? The solar system contains many small objects that, like the planets, orbit the sun. Scientists classify these objects based on their sizes, shapes, compositions, and orbits. The major categories include dwarf planets, comets, asteroids, and meteoroids. All right, areas of the solar system. Most of the small objects in the solar system are found in three areas: the asteroid belt, the Kuiper belt, and the Oort cloud. The asteroid belt is a region of the solar system between Mars and Jupiter. Beyond Neptune's orbit is the region called the Kuiper belt, which extends to about 100 times Earth's distance from the sun. Beyond the Kuiper belt, the Oort cloud, a spherical region of comets, stretches out more than 1,000 times the distance between the sun and Neptune. So figure 1 shows the areas. All right, so areas of the solar system. The diagram below shows the relative positions of the asteroid belt, the Kuiper belt, and the Oort cloud. As you read this lesson, write a C to show where a comet would most likely come from. Write an A to show where you would expect to find an asteroid. So in these two pictures, a C for a comet and an A for an asteroid. All right, vocabulary, Greek word. The word comet comes from the Greek word kometes, meaning long hair. Why do you think this word is used for comet? All right, dwarf planets. What happened to Pluto? You may have found yourself asking this question as you learned about the solar system. For many years, Pluto was considered a planet, but then scientists discovered other objects that were at least the same size as Pluto. Some were even farther away than Pluto. Scientists began debating how to define a planet. So defining dwarf planets. In 2006, astronomers developed a new category of objects called dwarf planets. These objects orbit the sun and have enough gravity to pull themselves into spheres, but they have other objects in the area of their orbits. As of 2012, scientists have identified 5 dwarf planets: Pluto, Eris, Makemake, Haumea, and Ceres. Eris is believed to be the largest dwarf planet so far. There are at least a dozen more objects that may turn out to be dwarf planets once scientists are able to study them. Like planets, dwarf planets can have moons. Pluto has 5 moons, among them Charon, Nix, and Hydra. Haumea has 2, and Eris has 1. All right, Kuiper belt objects. All the known dwarf planets except Ceres orbit beyond Neptune. Ceres orbits in the asteroid belt. Most of these dwarfs beyond Neptune orbit the sun in the Kuiper belt, though Eris may be beyond it. The Kuiper belt also includes many other objects that are too small to be considered dwarf planets. All right, down here. This figure shows one artist's idea of what the surface of Pluto looks like. Do you think Pluto should be considered a planet? Why or why not? All right, comets. A comet is one of the most dramatic objects you can see in the night sky. On a dark night, you can see its fuzzy white head and long streaming tails. Comets are loose collections of ice, dust, and small rocky particles whose orbits can be very long, narrow ellipses. Some comets have smaller orbits that bring them near Earth regularly. Most comets originate in the Oort cloud. All right, so a comet's head. When a comet gets close to the sun, the energy in sunlight turns the ice into gas, releasing gas and dust. Clouds of gas and dust form a fuzzy outer layer called a coma. Figure 3 shows the coma and the nucleus, the solid inner core of a comet. The nucleus is usually only a few kilometers across. All right, now a comet's tail. As a comet approaches the sun, it heats up and starts to glow. Some of the comet's gas and dust stream outward, forming a tail. Most comets have 2 tails, a gas tail and a dust tail. The gas tail points away from the sun, and the dust tail points along the path the comet has taken. A comet's tail can be more than 100 million kilometers long, and from Earth it appears to stretch across most of the sky. The material is stretched out very thinly, however. All right, so here, write a few sentences to summarize the structure of a comet. And then down here, a comet's orbit. Comets, as shown here, have long, narrow orbits. Their tails tend to grow longer as they approach the sun. All right, so complete the diagram above by adding the comet's tails. So up here, add their tails as they go around their orbit. All right, asteroids. Hundreds of small, irregular, rocky objects orbit the sun. These asteroids are rocky objects, most of which are too small to be considered dwarf planets. Astronomers have discovered more than 100,000 asteroids and find more each year. Small bodies. Most asteroids are small, less than a kilometer in diameter. Only Ceres, Pallas, Vesta, and Hygiea are more than 300 kilometers across. Ceres is both a dwarf planet and the largest asteroid. Most asteroids are not spherical because they don't have enough gravity to affect their shapes. Scientists hypothesize that asteroids are leftover pieces of the early solar system that never came together to form a planet. Asteroid orbits. Most asteroids orbit the sun in the asteroid belt. Some, however, have very elliptical orbits that bring them closer to the sun than Earth's orbit. Someday an asteroid will hit Earth. One or more large asteroids did hit Earth about 65 million years ago, filling the atmosphere with dust and smoke and blocking out sunlight around the world. Scientists hypothesize that many species of organisms, including the dinosaurs, became extinct as a result. And that's just a hypothesis they make. All right, apply it. For each description below, classify the object as a dwarf planet, comet, asteroid, or meteoroid. Let's read about meteoroids first, and then we'll come back to that. All right, meteoroids. Chunks of rock or metal smaller than asteroids are called meteoroids. Meteoroids are generally less than 10 meters across. Some meteoroids form when asteroids collide. Others form when comets break up, creating dust clouds. Meteors and meteorites. When a meteoroid enters Earth's atmosphere, friction with the air creates heat and produces a streak of light. This streak is a meteor. People often call meteors shooting stars, but they are actually not stars. Most meteors come from tiny bits of rock or dust that burn up completely, but some larger meteoroids do not burn up. Meteoroids that pass through the atmosphere and are found on Earth's surface are called meteorites. Meteorite impacts can leave craters, such as the one shown in Figure 4, over here. All right, meteor showers. Meteor showers occur when Earth passes through an area with many meteoroids. Some of these groups of meteoroids are bits of comets that broke up. These meteor showers occur every year as Earth passes through the same areas. Meteor showers are often named for the constellation from which they appear to come. The Perseids, Geminids, and Orionids are examples of meteor showers. All right, Meteor Crater. Meteor Crater in Arizona formed about 50,000 years ago from the impact of a meteorite, 50 to 100 meters wide. How would a large meteorite impact affect Earth today? Okay? Don't forget to come back to apply it, read each of these descriptions, and determine if you would label that a dwarf planet, comet, asteroid, or meteoroid. All right, for assess your understanding. Review. So comets or asteroids are rocky, while comets or asteroids are made of ice and dust. So either circle comets or asteroids for the first fact, circle the other one for the second fact. All right, describe the properties of a dwarf planet and an asteroid that make them different. How and why does a comet change as it approaches the sun?